Hey everyone, this is Eugene, and today we are with Chad, Willem, Matt, and Mike, and we're gonna record another episode of live contract reviews. Today we're gonna review near.bet. It's a website that allows you to sell accounts on Near mainnet. So it's kind of like a domain marketplace. And let me present. So first, my CPU is going crazy because I'm doing something in the background. So hopefully it works and we can review the second contract without an issue. But let's actually start with the first contract. So there's two parts, and one contract is kind of a lock and lock contract that you have to deploy on the account that is for sale. And this contract works like an escrow. It holds the account until the marketplace releases it. And you need to remove all access keys first on your account that you want to do for sale. So there is a special website. It would probably be better if I demo it, but I'm not ready for this. And once you deploy this contract and you remove all access key from this account, it's ready to be listed. Then on the marketplace, you will be able to bet on it, then claim it, and also list them. So let's first review the lock and lock account contract. So it uses Near SDK almost latest. I switched to latest, which is 301. And this is a contract. Then we have an external callback to itself. Then we have a helper is promised success. And it only has the owner account ID. So it has a lock that only can be called by itself. And it uses ignore state because you can do this multiple times. So you can initialize this contract on top of the contract that was already there. So let's say you sell in your account that has a multisig on it. So it already has state. So in order to operate on the existing state, it has to ignore the existing state.
But this will overwrite the existing contract with this
Yeah,
one,
it
right?
will override the existing contract as well as override the existing state key. So this
So basically,
currently,
I'm done using, it's like I'm done using multi-sig. I want to sell it now.
yeah,
That's what I do.
it also has certain limitations, such as limitation of the protocol, such as you really cannot delete the state yet. So in order to delete the state, or like entire contract storage state, you have to iterate on it and then delete each key individually. Or you can delete the account and recreate the account. But assuming this is uh, an account that you want to sell, you don't want to delete it and try to recreate it because you don't control .near account. So you would have to use something like another link drop call to register this account again. So someone can front run you. Or Near may not even allow you to recreate it because it's not aware that the account was deleted, so it will be gone forever. the link drop. So, okay, so it checks that it's called by itself, which is kind of secure as long as this is not a callback that can be triggered from this account. Now it initialized the owner, and you have unlock, which takes a new public key to add. It verifies that the owner calls it. I guess the owner in this case is a marketplace or the owner. It cleans up the owner for some reason, which is getting an empty string. And then it makes a promise to itself to add a full access key and also adds a callback. So what it doesn't do is return this promise. So you kind of will get a success, but maybe this can fail internally. So you'll get an early completion of the task. So to address this, you would use something like, I want to promise, and then return it. Get owner returns the owner. And the trick that we recently learned is you can do this. So you can just deserialize yourself into consumable object and just return the string instead of cloning it. Now, this is a callback, and you pass a predecessor, which
Question
is
about that.
owner. Yeah.
Consuming self for a view call. That's it's an optimization, like you're saving validators a little bit of computation, but it wouldn't cost you anything anyway.
Correct, yeah.
Okay. Looks nicer too, so.
We can use the private macro on the callback, right?
Yeah. Yeah, that's where the private macro comes into play. And this essentially eliminates the need of doing this manually. So it's exactly the same thing. So it checks if the access key was created. And if it was not created, we recover the owner ID and return true or false. Well, this Boolean is actually never returned because this promise was not returned. So the original transaction will not have a result of true or false, but the receipt that was kind of forked it into this promise was doing it. And that's it. So this is very simple contract. It kind of has a access control by just doing this. So like once you actually succeed in unlocking, you're done. And it attaches 20 teragas on this call, which is probably not needed. So 5 teragas should be enough for this. But it does look secure. So what it doesn't do is doesn't delete this account. So potentially,
So it doesn't, it feels like there's still a full access key on this account that you're auctioning.
oh yeah, so this is handled by frontend because we don't really have a way to go through access keys in a contract level. So that's a limitation that we currently have, and that's how the contract actually works. So there's a frontend that deletes all access keys, including the full access key, the final full access key. Once you've done this, lock it towards the marketplace, and then at the end of this, the marketplace will be able to unlock it towards a new owner.
So then is the owner ID that's always going to be like marketplace.near, basically?
Something like this, yes. Well, not necessary. You can reuse this contract for other cases, including testing. But yeah, it seems fairly simple and it looks like it's working. And yeah, and another, like, as we mentioned, a few cases is like decrease the gas, return this promise.
How do you know you can? I know we've covered this on previous videos, but how do you know that gas number off the top of
Cool.
your head?
We should actually add this to the best practices that we're doing, like the gas management. So the way you think about gas is, are you doing any access or like any complicated work? If not, if you don't have any complicated state in your contract, you likely will fit fine into 5 teragas because it's enormous amount of compute for just a regular operation. So this is probably around, I don't know, less than 1 gigagas, so like around maybe a little more, like a few gigagas operations, because it actually just in-memory operations. So like once you in the method, it doesn't cost you almost anything. So there's cost on this, on parsing it, cost on deserializing the contract, and then cost on writing the contract back. So usually it's under 1 teragas for all of this operation. So the internal compute, even with state operations, is usually doesn't really cost anything significant. So that's why 5 teragas is like upper limit that is usually safe on just basic compute storage operations and stuff like this. Now when you do a function call, so this piece does a function call, this costs around 5 teragas. So the function call itself costs around 5 teragas. So every time you do a function call and you promise towards the function call, you need to think about, I just added 5 teragas. Adding a full access key, I don't remember how much it cost. We probably can look into the runtime config to figure out how much it costs to schedule a promise. And this is a self promise, which is supposed to be cheaper, but it's not. And adding a key is usually a fixed size operation, which is reasonably cheap. Now, the only extra cost is .then. Right now, it's overpriced, and it costs around 10 teragas. So adding a dependency on the promise costs 10 teragas, and this is like completely overpriced. So when we did a correct computation of how much it should cost, it costs something like 50 gigagas. So it's like 2 magnitudes cheaper than what it is right now. And the reason for this, it's mostly covered by the extra promises. That's already scheduled all the receipts for you. So
is that something that can just, I have no idea. This is probably a really dumb question, but is that something that can just be changed in Genesis, being like, oh, actually, bink, 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 change the number.
So yeah,
Then
that's
cheap.
not in Genesis. You need to like actually do a protocol change that upgrades it live. So you need to have a block before this to aware that next blocks is going to do a protocol change, and the next block actually triggers the change in the config, so all the execution goes with the new config. And I think we've done one config change so far, but nothing major. So we did something that we needed.
Storage cost.
Storage cost is probably the one that was fairly simple change, but same way you can modify any config. The reason why we still haven't done this is because we're waiting on recomputation of function call. So we want to bundle it with the rest of the changes, which includes, first of all, default promise gets more expensive. So like a basic promise call will get more expensive because we were underestimating the depth of the try. So it will be like 4 times more expensive or something like this. that makes certain actions cheaper because now we shifted the cost into the base. And like adding a new key is not as expensive. Then, as I said, it's super cheap, but this one, it depends on cost of deserializing the contract from the state. So right now, it is reasonably high and slow. So we want to bring it down. So there's some optimization work that this contract runtime is doing on bring it down to the reasonable cost. I think so. Right now it's something like 600 gigagas for the like small contract, but it may have to depend on the contract size or something like this, or like have some like higher base cost. And that will still drop it a lot. So boss function call will be cheaper and .then operation will be cheaper because in reality, they don't really cost as much. So major cost that we have right now is compiling the contract. And compiling the contract is currently assumed to be done at the runtime. So when you call a contract that was never called before, we assume you have to compile it. And in a runtime right now, we assume you have to compile every single contract every time you call it. So we assume you have zero cache. But what will be changed is the deploy action. So the action that deploys the contract will compile the contract because you do this only once, and deploying the contract can be a bit more expensive because it's a one-time operation that you do, and you pay for deploying it into the cache. And this operation will kind of compile the contract, store it on a node in a compiled cache, and then node will be able to deserialize it at the moment when you need to call it. And that can bring down the cost of the function call. So overall, the base will, like the most common operations, all of them will be extremely cheap compared to what it is now. And it will not incur this like dependency extra cost that right now have. So a simple method that does a call and a callback costs around like 25 teragas right now because of two promises that it makes to like remote call and a callback and a dependency that is 10 teragas plus 5 teragas to compute. So instead, once you update it, it might be like 2 teragas for the promises plus dependency and 5 teragas for call. So you have only 7, and that allows us to like rescale how much you can do the dependency, like how fast they fly. Okay.
Awesome.
Let's go jump into the marketplace. Let's see if my problem disappeared. Build, retry. So we just published a simulator, so that should work. Okay, so this is based on Berry cards. So some of the stuff may be familiar. So you have profiles, bids, top bets, top claims. So this is to create a leaderboard, number of offers. So this statistics, total commission, acquisition time. I don't know what is acquisition time. Owner ID, DAO ID, contract extension. Oh, interesting. So this is probably for contract upgradability. And so the way you would use it to upgrade your contract, you can create you can basically replace this with something else. And because it's none right now, you can create a second version of the contract. So the burst serializer serializes this option into 1 byte. That's kind of cool. Okay, test new. So this is not needed in USDK. It gets acquisition time and DAO ID. And set up a bunch of maps, U, A, B, C. Defaults, owner ID
like
is a signer ID. What's up?
Looks like we need a capital U 64.
Yeah, it depends on like what's the size of this. If it's a nanoseconds, then yes. If it's a microsecond, then probably not. But yeah, I wish we don't have to think about this. Okay, so the difference between two is the test new takes the acquisition time versus regular new takes the owner ID, and it sets the acquisition time to some constant, which is 72 hours. So this is the amount of time, I guess, needed to get the account. And it has...
That's the full auction time, or that's just the like finalization time or something?
It's when you're trying to claim the account, I assume. Well, actually, I don't know. The mechanics we'll see. I don't remember the exact mechanics. So this is a bunch of statistics. And that's it. So let's see something like bits. Actually, let's go into maps. So we have profile ID, which is account ID, and bid ID is also account ID. And then a profile is a structure
stats.
representing an account. So it has a bunch of stats per account. So this is how like Barry Cards was done. So it had a lot of data on every account level on the contract side. It's kind of waste of gas, but at the same time, you don't need an indexer to get this information if you want to. Okay, so it has a participation, an ordered set of bids and acquisitions. It's what it did, what this account did. Then there's a profile view that returns it. So I don't think this is gonna work very well if you do too many actions, unless you removed from them as well, because this may run out of gas when you iterate in the set. Not not sure what bid does because they both bid, so you don't really need this map, and you can just convert it to a vector. So I think I'm not sure if an ordered set has 2vec, but it looks like it may have. Yeah. In this case, you can just call 2vec. Because they both bid. Okay. So
I think
because
again those lowercase u64s if we're using JSON Serde. But
I
anyway,
mean, they cannot really exceed, so they probably
What-
never exceed U32, and Serde is fine with U64. So it's a JavaScript that is not. So like if we ever exceed this number, the JSON on the JavaScript side, then we'll have a problem. But on Rust side, Serde is okay with the long numbers. So yeah, these numbers are not balances, so that's why then they don't need to be converted. All right, so on rewards collected, some callback. Okay, so we get to the methods of the profile. You can get a profile by profile ID, and it gives you a view. You can, oh, I see, no. Collect rewards. So this is a method to kind of claim rewards, extract profile or create for the predecessor. Then you get available rewards. If rewards more than minimum rewards, then we return this message. Okay, so we set available rewards to 0. We increase the profit by the number of rewards. We say we save this profile. Oh, panic. What does this even mean? Assert there was no such profile. So it basically verifies that there's no such profile. I guess extract pulls it out. Right. That says fine. So this is logic to create 2 extra unordered sets and prefixes based on the profile ID. But it does remove this profile every time. So maybe it's like a safeguard or something like this. Okay, so when you save this profile, you want to do a transfer to the predecessor and you transfer rewards, and then on rewards collected, you have a callback that takes a predecessor and rewards, and on rewards collected, again, it's a private method. It checks if rewards were not transferred, then we return the rewards back. We kind of roll back this operation. And then we return whether it succeeded or not. So it's kind of safety that you didn't delete your account and accidentally will lose your funds, which is cool. And here we actually return this promise. So this is good. So again, this is 2 methods: save, update, reward. Okay. Cool. Anyway, let's go to the next piece, which is action. So what you can do, and there's a ton of actions. So let's see. First, you can offer a profile ID, and no, it's an offer. So you need to attach Mozen offer deposit, which is a lot of zeros. So this is about 0.03 near at minimum. We verify that you don't call it from your own account ID. Then we do some bit. So we actually haven't looked into what is a bit. The bit is a bunch of bets, which is vector of account of profile IDs who betted, participants, and claim status, and number of claims. Okay, so calculate the bet. Internally, it iterates over all bets starting from 1 and multiplies it by the length. So if one account gets too many bets, that will be expensive. Now that will be like expensive in terms of gas. But bet grows by basically 20% every time. Yeah, but it doesn't read the bets. It's just kind of like power formula.
Yeah. I don't want to throw too much of a wrench in here, but last night I've been thinking a lot about just like this is a common problem we have to face. Is like I have a task that's going to probably take more than one transaction. What do I do now? And it seems like there can be like an approach that we can recommend, almost like a standard. And this is a perfect use case of that, where it's like you got to use pagination, you got to keep calling the transaction, and maybe the transaction will say like, "There's still more to do," or like, "We are done with this task," or something like that.
Yeah, maybe like save this computation into the state and then say you need to continue this computation.
Right.
Okay, so force calculate claim price, calculate bet price by 2, calculate claim price. If it was not claimed, then you kind of calculate this. Otherwise, none. What? If none, then this. Otherwise, none.
If none, some, else
Some.
none.
Yeah, what's going on here? I guess it, but this one doesn't store it. So what's the magic here?
That's where code comments are great.
Calculate forfeit.
But it's calculating the price. So it's saying if there's no,
If it was not claimed, then we're gonna do the compute. If otherwise, we don't do the compute.
right.
So basically, if not claimed, then this. Otherwise, none.
Otherwise, it's not for sale, so there's no claim price. Or it can't be claimed, rather.
It was already, like, if it was already claimed, then that's it. But if it's not, then here's the price. Forfeit. If we get the claim status. Then we calculate bet price. And then we say time either 1 what is this? But this is okay. Multiplied by this number. What? Okay, that's kind of to divide nanoseconds, I guess. Yeah. Okay, commission for claimer for marketplace. I don't know what it is, but on acquisition, if there was a claim, then it returns whether. Okay. I'm not sure what's going on here. So there's a view call that goes through a map.
What does the implement from for bid view give you? Where does that get used later?
It's probably when you do dot into, and it returns you something like bid view in a here. So like you do dot into. Doesn't it does acquisition time here. It just sums it up. Okay, get bid gets you the current bid for the bid ID. Get top bets. It basically constructs the key and iterates from a tree map to do this. Then top claims, again, just a view calls. This is helpers. So again, this is like more prefixes. So you need to make sure you don't repeat them. So that's where the new suggestion of using like a storage key will be helpful.
Is it worth re-going over that in this video, or will we just link to the previous one in
Yeah, we can
in the show notes?
link to the best practices in the show note. Extract bid or panic. So again, say bid or panic, clear bid. So it clears this, clears participants, and sets claim status to none and none actions to 0. Okay, so majority of logic is off this. So this is just a bunch of helper, and all of the actions apparently are in the action.rs. So get the bid. We insert your profile into participants. We get your profile. Then we say number of offers. Say the profile, so we insert the predecessor. I guess you say who is the beneficiary, but I'm not quite sure how that works. Okay, bet and update. I guess I had to look into front end to better understand the mechanics, what calls what, because it seems like this method might be called by the account that is actually listing itself. So updating bet leaderboard.
But if it's called by that account, why do you need to pass in a profile ID?
This is the beneficiary of the sale. So who will get the proceeds of the sale.
Gotcha. Okay.
Okay, let's see what's going on here. So we calculate the new price. Then if there's no bets on this, then the current offer is initial one. Update commission. What is update commission? We pay down the commission. So initial offer goes to the DAO, then top bets are removed. So this is similar to berry cards. So we remove first, then we update the commission. So interesting that this piece actually pays commission. It's kind of like, hey, we're gonna update the leaderboard, but also we're gonna pay some commission.
It should be called bet and update leaders and pay commission.
Right. So we go and update reward. What is update reward? So we pay this profile some tokens. So for people who betted early, they got paid into some value from this. So this one is 144. So there's economics actually that explains it, but we can ignore it for now. So amount of paid decreases by the amount we just paid. So this can be actually extracted so you don't do this twice. Then we pay the original better, the first better, the rest. Bet price minus the bet price divided by commission. So we pay everything except for 20. That's a lot. Okay, got it. And we increase the price. So when you rebet, you kind of cover all the commissions of the previous bettors. Then we insert this new bet on your profile. Then we update the top bets. But we do not update the top claims. So where is the top claims? Maybe here. No. So it's unclear, like where's the top claims happening? Because we did remove it for some reason. Maybe it's not there at all. Okay, let's go back to actions. I am in actions. Okay, let's go back really far. Okay, so top claims are not really. Maybe you kind of cancel the top claim by doing it. Okay, let's continue. there is more stuff to do. So when you bet, we do compute we get the bet, we say on acquisition, was it acquired? You cannot bet if it was already acquired, so you have a time when you can claim it. So if no one else bets that you will claim at a higher price, then the bet goes away. Then the account, you kind of claim it. So you have 72 hours that no one will bet on your account that you're trying to claim. If not, then then it fails. So forfeit, commission.
Do you know if the UI calls it bids or bets?
Yeah, it's kind of like a bit weird because you have bids and bets. Right.
It seems like bidding is the better mental model for this app.
Yeah. Okay, so we calculate how much forfeit, claimer profile, and we give force calculate claim price, we return, and we also provide the forfeit. So basically, when you're trying to claim, if someone else outbid you, they will pay you extra. Then you need to pay more forfeit and commission. Then we say you didn't claim, we say who participated, extracting this profile, returning, and we update the account. Cool. Finally claim. So we get the bid, we calculate the claim price, we say that you need to attach more, then we set the claim status, save bid or panic. Okay, and we insert top claim, which is double the price. So I guess this 2x bet price was coming from this calculation. But what if someone already claimed it? Where do we check? Oh yeah, here we check that if someone already claimed it, then if you want to claim it, then you need to first bid and then claim it. Okay. And finalize is the method that allows you to finalize the acquisition. So the acquisition should complete and you get the profile. I guess you can use unwrap here, like sref unwrap. Then you do get the profile. You say you acquired this account. Then we update final result. So this is gonna redistribute the funds. We remove top bets and we remove top claims. So we remove this from leaderboards. And we clear the bid. completely from storage. So you now have this account that you can take. So you acquire this. So you pass the bid ID. We remove this acquisition. It should return true. So this method probably should take one Yoctanier, because you can kind of like, it's kind of a method that doesn't require a touch deposit, but it takes ownership of the account. So ideally, you don't want to let it just do this with access key. So we remove the acquisitions, then we get the key. Why it's a string. All right, so we cast it back. Well, you don't need to convert it then at all. So yeah, so this can be done using an external call. And what if the promise fails? Right, so unlock essentially was not doing a promise in the past, so now it does a promise. And how much gas it attaches, 100 tera gas, so that should be enough. Right, so this can be re-implemented a bit with the external method. And finally, this is what we reviewed. Update final rewards. We haven't looked. So we go through all participants and we remove their participation. We calculate the price and then we go and pay them off, similarly how we did before. Inverse founder commissions 1/4. Anyway, so it just pays off everyone who need to be paid. And that's it. Yeah, overall, kind of everything is secure, except maybe in a few places you may run out of gas, but it doesn't do any promises, so you're kind of safe there.
I had a quick question about that very first short contract we looked at.
Yeah.
So there's like owner ID on there. This is just like that really small one that you
Yes.
deploy to your own account.
Yeah.
Like, does owner ID get wiped out when if you decide to buy a contract and then deploy a new contract over it, and it also has owner ID on the contract struct?
Yeah, it does wipes it out during the unlock. So like once you try to unlock once, it basically removes the owner ID, but if unlock fails, it puts the owner ID back.
Okay, I guess I mean like if they want to do a totally different contract on this, they just purchased it, and they also have like an owner ID field. Is it going to freak out by like, hey, we're trying to add to the try?
Yeah, that's why like it uses ignore state. So the better solution, if we can actually clean up the state after ourselves, so we can delete it.
Okay.
It seems like maybe ignore state is fine on lock, and then on unlock you want to clean up state?
In theory, yeah. So here, after this thing is successful, like actually, all right, so I mean, this cannot really fail unless there's already an access key. So what you want to do is you probably want to delete state here. So this should be like some magic method that doesn't write state at the end, so which we don't really have. So it should be like a view call, but not a view call. And then it deletes the state by deleting the state key. And here you may, instead of calling yourself, you just delete the contract by saying like it's to none. Okay, so I'm a bit over time for my next meeting, so overall it looks like it's working. The economics can be made a bit cleaner in a contract. There's a lot of boilerplate around like how this is done, where we grab the account, then we update it, and we have to set it back. So it would be great to maybe one way of doing this, you can use some kind of Azure Lambda that you pass, like one-time method, like update account, or you grab the account wrapped into something. So you extract the object that you know you're gonna put back at the end once it's dropped from state. But that's for another time to experiment with this type of patterns, because this is very common. Like how frequently you need to do this. Like almost every single contract that operates on this type of stuff does this right now. And this because we operate in like singleton for the contract, and then all the methods are not, all the objects are like temporarily leave. Same for bits. Like here, we get rid of bit. So I would think the way you do this is maybe you have something like, one option is you do this, you put it into sub block. At this moment, bit is dropped from memory. So maybe you have a version that is writes it into the state when the bit is dropped, unless you call something like helper there. So like, no, don't drop it, or like don't write it into the state. Or as I said, another version is you kind of call self bit, or this bit maybe, and then you do pass the bit ID, and then you pass something like bit, and you do a bunch of operations here, and like this. So, and here you take this mute bit essentially.
Could this be implemented with a helper macro in near SDK RS?
Yeah,
Like
it can
a
be like part of the
update
map
or something?
essentially. Yeah, part of the map, and can be called update that does this thing. So it
I'm
would be, like,
picturing almost
much
something
cleaner.
that's like update and then bid colon and like the thing to update bids
But
with.
yeah, then you need to have insert this. So you need to insert this bit if it doesn't exist. So this one is like initializes with somewhat almost as default, except you need this bit ID. Maybe
Yeah, I could see doing like
take it just with default. So it requires default and bit. Anyway, I'll stop sharing. And thanks everyone for listening. I hope it was entertaining, and see you next time.
Thanks.